Okay, we can roll. Hey, everybody. Nice to see everyone here. Um, so today I'm going to do maybe a 20-minute presentation on glutamate. Glutamate is a neurotransmitter, and glutamate is a neurotransmitter that causes a lot of excitation, so it turns things on. Glutamate is found, it's a G protein that transcends the entire phospholipid bilayer, and it is present throughout almost all the tissue in the body. And so when you activate glutamate, you get an entire systemic response. You get a systemic response in the entire organism. And so here, let me go through this presentation first. So, and then I have several of my team members here, and so several of my colleagues. And so I'll get into the presentation, and then when you feel comfortable, you can just raise your hand. I don't want to just put you on the spot. So, since this is your first stream, this is my second stream, so I'm not you're not too far behind me. Okay, so here. And we're going to take these materials and also use them for the students to sort of learn on. Also in the link, if anyone wants to join our team or become a patient, they can just click on the link and get access to us and schedule an appointment from there. Okay, so first, glutamate is a naturally occurring amino acid. Okay, plays a vital role as primarily in excitation. Okay, the central nervous system. It's involved in a wide range of brain functions: learning, memory, communication. Oh, it's a flavor enhancer. I didn't know that was this. I didn't know this monosodium glutamate was the same glutamate. I didn't know that. Okay. Okay. Um, okay. So let me look at the role of glutamate as a neuroreceptor. Is the most abundant excitatory neurotransmitter. Um, it stimulates cells to transmit signals. So, because glutamate is present throughout all the tissues, when you produce, since the receptors are present throughout all the tissues, when you produce glutamate, it has an excitatory response on all of the organ systems. So, it tends to stimulate the entire organism. As you can see here, it increases transmission of the nerve, the signals going across the nerve. So it increases the network hyperactivity, it increases network activity. And that's the main problem we see when patients come into the emergency department. We see acute excitation, right? And so it gets so out of hand that we have to use medications at times intramuscularly to sort of calm them down. And so in this case, a lot of failure of these systems actually result in excitation or overactivity. Um, we have to handle that. Um, so it also plays a role in learning, memory, and overall neuronal communications. But I think this neuronal communications is a very important part here. I think that's why the patients have it's so difficult to treat agitation, because it involves so many organ systems. It's just not one organ system. If you use some of the medications to decrease the psychomotor activity, like decrease the muscles, where you still have the respiratory rate really high, you still have the heart rate really high, and so it's tough to treat patients with this overexcitation, and then they can be very unpredictable. Okay, MSC, a food additive. Okay, naturally occurring. Okay, here it is. In excess, glutamate can be toxic to nerve cells. This is the key here. So, all the things that causes excitation, if it does it too much, it can cause the brain the cells themselves to die. Ecstasy, right? Ecstasy hits the NMDA receptors, which causes excitation, overexpression of glutamate. And in many of those patients with NMDA or ecstasy, they start to have the memory and the brain damage associated with ecstasy use. And we pick it up on a unit with them not being able to recall or remember as many items. Same thing with the cocaine, overstimulating dopamine release and then glutamate overexcitation. So this neurotoxicity is a common it's a common pathway for injuries to predictable parts of the brain, particularly the hippocampus and where the memory is located in the prefrontal cortex. And so you see things like ecstasy, methamphetamines, cocaine. All of these are very things that target dopamine release, and so it causes a lot of excitation. And the patients who typically use those typically have the cognitive deficits and the memory problems associated with the damage that comes from overusing these substances too much or using for long periods of time. Here, glutamate receptors here, they interact with specific receptors on nerve cells. Here's MNDA right there again. Yep, here's the MNDA ecstasy, right? Okay. Now, if GABA is yin, then if glutamate is yin, meaning excitation, then there must be another neurotransmitter that sort of serves the same function but turns everything off. Because it has to be some balance in the system, right? So there's also another neurotransmitter that's present, same thing like glutamate throughout almost all of the tissues. And its primary role is to turn things off. It's inhibitory. And that's GABA right here. So glutamate turns everything on, yin. GABA turns everything off, yang. This is why substances that target GABA are preferred. So, for example, alcohol targets GABA. Specifically, I believe it's the B site on GABA. Alcohol activates GABA. GABA imposes inhibitory tone. GABA balances glutamate the same way yin balances yang. And that's why patients with substance abuse issues, particularly alcohol dependency issues, may have to continue to drink GABA in order to balance their system for themselves. And what happens if the person who's dependent upon drinking GABA happens when it stops? When the patient can no longer activate GABA on themselves, then they don't get the inhibitory tone. So what happens? You get excessive excitation, what alcohol withdrawals, right? That excitation can get so bad that after like 12, 24 hours, they can have seizures. And if the agitation gets so bad, they can begin to have a delirium, specifically known as delirium tremens. And so that's glutamate. And let me see if I can take any questions so far. Let me see if I can go to the comment section, or if any of my colleagues would like to have any input or anything like that, just please raise your hand, let me know. Okay. So if anyone have any questions, okay, the first question I have here is, can too much glutamate actually damage the brain over time? Yes, 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 yes. And that's the problem. That's the problem. Remember, with patients with chronic severe post-traumatic stress disorder in that hyper adrenergic state, high cortisol, high adrenaline, really over excitation with glutamate, those patients like that typically start develop memory problems. Because the same high cortisol and the hyper glutaminergic state causes brain cell death, and that's probably one of the mechanisms of cognitive dysfunction and memory dysfunction in chronic untreated PTSD. So it can bring over time. I say that's an example over time with chronic PTSD. That's why child abuse and unresolved early childhood events are so traumatic, because they bring those childhood traumatic experience throughout their lives, and they have difficulty escaping from those experiences. the glutamate actual brain damage. In the case of methamphetamines, they made that drug is so potent so potent the overdoses may result in overexcitation and then eventually cell death. I think it's more through a process like Wallerian degeneration, something like that. But you can get the definitely brain cell death, and we pick that up on the neuropsych testing when we test as the patient to remember 12 items and try to see how many they can remember. So we pick it up there, and the deficits are rather severe. In fact, let me show you a few studies just to let you know how prominent this is. So we talk about glutamate impair memory retention and damage repairs retention and damages hypothalamic neurons. I don't think you want to deal with. See, you don't want to deal with neurotransmitters that target everything, because if you go wrong there, the whole system goes wrong. Look, involvement of glutamate in learning and memory, glutamate dysfunction in Alzheimer's. Okay, the pathological changes. Let me see here. Okay. Come on, man. Where the article at, bro? Okay. Only available in PDF. Okay. We are present. Okay. We present evidence to support the hypothesis that glutamate dysfunction is involved in the pathology of Alzheimer's disease and can account for many neurochemical and biological deficits observed in disease. I think when they say glutamate dysfunction, it's probably like too much glutamate, not too little glutamate. Okay, so as you can see, there's a relationship between the two. Let me see if I have any other questions here. Okay, what happens if your brain doesn't make enough GABA? Yeah, GABA is inhibitory, so you don't have the systems available to turn all of this excitation off. And so I would say that that's a situation like acute agitation and frank agitation, where you become disinhibited. Disinhibited. Okay, let's see here. Next, Huntington's disease patient has lower GABA. So what would be one example? No, I don't. Okay, I mean, I don't think I can talk about low GABA, high GABA. I'm talking about GABA activity, hypoactivity or hyperactivity, just like glutamate hypoactivity and hyperactivity. I think I'm talking more like that. And I don't think your body's ever out of GABA. Is still is the activity is decreased compared to glutamate activity. So you want to keep the ship. Glutamate makes it more active because GABA is low, and so you want to keep those two balanced. But you're never out of glutamate. And off the top of my head, I can't really off my head remember the connection between GABA and Huntington's disease, because Huntington's disease involved the CG pair, and that's more located in the basal ganglia. That's really regulated by dopamine. So, but we were talking about GABA that's regulated throughout the entire system. So the Huntington's disease is a specific part of an organ system. Mainly, I believe it's the intermediate loop in that basal ganglia structure. Next question: if glutamate is too high due to alcohol withdrawal, what should we prefer, typical, atypical antipsychotics to balance out in GABA? Yeah. Okay, so alcohol withdrawal is basically secondary to the person was activating GABA with liquid alcohol, and so you simply want to try to replace that with tablets. And so when they come in for detox, I can put them on Ativan, 1 milligram 3 times a day, and just schedule it like that. And then I give them the medications like every 4 hours as needed. So if they started having more withdrawals, they can get more medications as needed. And so I've been very fortunate to be able to handle the alcohol withdrawals in that matter. Now, when it gets to the point where they may have alcohol withdrawal related seizures, if they're at risk, I'll put them on decode just to sort of help decrease the likelihood of that. If it evolves into more of a delirium tremens, then now you're going to have to use antipsychotics in this case, and you want to try to use Haldol. Haldol may have more evidence in that situation, so I would go with the for alcohol for the deliriums associated with alcohol withdrawal. I would probably go with Haldol. Um, as opposed to any atypical antipsychotics. I don't think that the atypical. I don't believe there's any evidence of atypical antipsychotics in delirium tremens. Let me look here. In atypical. Okay, the role. It's been a while since I've looked at this data. Okay, it was concluded that they appear to be effective and tolerable in a manic delirium, even though the evidence is limited. I still wouldn't. I would still go with the just the standard Haldol before I move to atypical antipsychotics. And the reason why is that the typical antipsychotics like Haldol have a a stronger binding affinity at the dopamine receptor, and you want a higher binding affinity if the network failed. In the case of the delirium, nothing's working well. So you want a potent antipsychotic to bind those receptors to stabilize things, not a weaker one, because this is an emergency. It's a kind of urgent situation. If a person can't pay attention, the person is confused. Okay, next, what does GABA have to do with anxiety and stress? Um, um, Anxiety, I guess, is the physiological reaction to the stressor. And I think the stress is just how you perceive the event. Um, but if it causes excitation, then it's glutamate. If you need to calm it down, then I would say it's GABA. GABA will be, let's say in this case, anxiety and stress will likely increase your heart rate, right? Possibly because of excessive glutamate flying around. Now, GABA, activation of GABA will likely decrease all those things. And you can activate GABA through people activate GABA through alcohol manually. Um, Let me see. Anna's question was so complicated. I didn't want to embarrass myself. Anna had maybe I could. Okay, maybe it's somebody. Okay, here. Now, naltrexone used for alcohol cessation, which is an oral opiate antagonist. Okay, what is the relation with GABA and opiates? And what is relation with GABA and what's the relationship between GABA and opiate in the brain? In terms of brain activities. Um, let me let me. That's a tough question for me. Did anyone want to comment on that question or anything like that? Or anyone want to make any comments so far? Okay. Okay, we're good. Okay, so Anna, let me just pass on that question because I'm not putting the things together. Okay. So also let me show you here. Okay. Okay. So what am I looking for here? Okay. The glutamate receptor is a G protein that's composed of at least 6 subunits. And this thing is really fascinating. This contraption is really fascinating. Let me see if I can find a glutamate receptor. Uh, okay, so let's look at this. Okay, apparently these are different type of glutamate receptors. Okay, here, this is what I'm looking for here. These are huge proteins that usually have at least 6 subunits, and they they transcend the entire phospholipid bilayer. And basically, they receive a signal on the outside of the structure, and they translate it to the mechanism on the inside in order to create a product, in this case, messenger RNA, that's going to be taken to the cell body, and that's going to be instructions to produce whatever, to do whatever it's instructed to do. And so these huge protein complexes are usually associated with either ion gates or any type of gates, and they usually control a lot of the functionality. So in this case, it's hard for me to remember the exact mechanism of glutamate in this receptor, but the binding occurs, and I believe it's the ion gate in close proximity to it that opens and causes depolarization. I believe the depolarization may have some impact on the excitation or how much it's excited. Don't quote me on that. It's been a while since I've read that about the functionality of the glutamate receptor. Okay, let's see. Okay, and let's see how long we've been going here so far. It's been 22 minutes, and so I think I'm gonna go ahead and I'm going to cut it short here. And if there's any questions, then let me know. If anyone have any other questions, then please let me know. Okay, somebody had a question? Okay, all right. Okay, so I'm gonna go ahead and end this stream. Thank you very much, guys, and I'll talk to you guys later. Okay, take care, guys.